This slide set is about network address translation, which is a frequently used method to deal with the lack of IPv4 addresses. In many local area networks, you just find end systems but no servers. End systems do not require to be reachable from the outside world under a well-known IP address. In addition, communication is typically started by end systems. Without network address translation, it is necessary that every end system has an own unique IPv4 address. However, due to the lack of IPv4 addresses, this is not easy and may imply additional costs. In addition, such an assignment of global IPv4 addresses may make it more difficult to change the provider. Even though NAT is also important for companies or universities, the typical situation for using it is a private home. A user has a DSL router or a cable modem for the connection to the ISP. The user has not only one device, but several devices. Maybe it is a family where different family members want to access the internet at the same time with notebooks, smartphones and tablet PCs. The ISP assigns only one public IPv4 address to the DSL router, which then also works as NAT router. It maps all addresses used in the LAN to the one public IPv4 address. We see how this mapping works on the next slide. It has to include port numbers to ensure a unique mapping. On the right-hand side of the figure, we see three computers. These computers have IPv4 addresses, but these IPv4 addresses are special because they belong to one of the private IP address spaces. Everybody is allowed to use these addresses locally, but they cannot be used in the internet to avoid ambiguities. So these computers represent devices of different family members. Now the host 10.0.0.1 wants to contact a server in the public internet. It sends an IP packet as usual. On the NAT router, it has to be changed because the address 10.0.0.1 is not allowed in the internet. It has to be replaced by the one public IPv4 address 138.76.29.7, which has been assigned by the provider to the NAT router. On the top, we see a mapping between the private IP addresses and the public IP address that the NAT router does in his NAT table. As you can see, it is not sufficient just to use IP addresses because we have several private IP addresses but only one public IP address. Therefore, the port numbers are used in addition. According to the OSI model, the task of the port numbers is to distinguish between applications. However, here the port numbers are used to distinguish between hosts. In addition, NAT also violates the OSI model because it changes IP addresses in the network so that IP addresses are no longer valid end-to-end. The modified IP packet is sent to the internet and afterwards a reply from the server in the internet is received by the NAT router. At this point, the NAT table is considered again to reverse the mapping that has been done before. So in the last step, the IP packet is delivered to the requesting host by using the private IP address and also the previously used port number.